about what we mean by AI.
Sorry.
Okay, recording has started. Okay, I'm not going to summarize a third time. So, hello, YouTube. So I would like to start the presentation by defining what AI is, because it's not obvious. The different advertisers in my examples have different ideas about what AI might mean. So the first half, I will talk about what AI means or can mean. And in the second half, I want to lead over to talk about how AI can be used in the digital humanities or in the humanities in general. So it's clear what AI might do in sciences, in medicine, and so forth, in business intelligence, but it's maybe not so clear if it can be used in the humanities. And then I will give a little literature review, some ideas about how AI is already being used in China studies in particular. And then we can have a little nice discussion. So I start the presentation with a quote by our famous beach philosopher: "The world is patterning." So if you think about the world as a big motion, as a pattern that is so vast that you cannot really make sense of it, then it's difficult for us as humanities scholars to really analyze it. And AI, as I will explain, is really good at pattern recognition and at recognizing patterns. Some of the patterns that you might think of in the humanities that you might be interested in, or that I am interested in, these are patterns like patterns in social organization, patterns in institutional history between generations, in transportation, in the market, mobility, social media, patterns in history of ideas, patterns in cultural diffusion. All of these patterns, they are so complex, so vast, that it's difficult to really analyze them by hand, by a single person. And this is something that, as I will explain to you, AI as a pattern recognition machine can maybe help us make sense of in the humanities. So as a clarification, what this talk will be about today, it will be about the application of AI in the humanities. Meaning, first of all, this is not a presentation about DH, digital humanities projects in general. So don't feel offended if I don't discuss your favorite digital humanities project, because as I will explain later to you, not everything digital is equal to being AI. It's a bit more complex. Second, this is also not a presentation about analyzing AI from within the humanities. So you might be working on a paper about the ethics of AI. And in this sense, you are a humanities scholar who's analyzing AI, but you're not using AI as a method. So this is also totally relevant, totally legitimate, but it's also not what this presentation today is about. And third, this is also not a presentation about how to use or not use AI in education and in classes. It's really fascinating. If you Google Scholar search AI in China, like 80% of the papers are about AI in education. And actually in our background talk, Sikun, you also told me that's a hot topic for you in your last conference. And I understand that perfectly, but it's also just not what this presentation is about today. So rather, it's about two things that are kind of overlapping. First of all, it's about AI as tools in research. So it's about how we can use AI as a tool aiding us in our research. And second, and more importantly, it's about AI as methods in our research. So how we can use AI as methods to advance our humanities research. But before we go there, I would like to have a little history overview. Maybe you can type in the chat what you think. How old is the term AI? You can type a year, like any 4-digit year in the chat, and maybe if you can win a prize, maybe, I don't know. Okay, some of you are very well informed. Okay, so you already get the idea. So because of the current hype, many people think that AI is a current development, a new thing, but it's not, as you have all realized, and some of you are really close to the truth. So we can start somewhere in the 50s for sure. We could start maybe by a famous essay by Alan Turing, the famous mathematician who is also a famous code cracker. And he wrote this article. He didn't get used the term AI, he used the term machine intelligence, but he basically defined machine intelligence. And that's really important, I think, as a machine imitating human intelligence. So it's not about a machine being intelligent. It's not about a machine thinking like a human. It's about imitation, about simulation. And I think that's always important to make clear. Just because a machine is programmed in a way to simulate human intelligence, it doesn't make it intelligent. It doesn't make it self-aware or even conscious. It's a bit like the mannequin, which is made in a way to simulate the human body, and you can put clothes on in just the way you could put clothes on a human body, but it doesn't make a shop mannequin a human. And I think that's always important to make this distinction. Artificial quote-unquote intelligence doesn't mean that it is intelligent as a human is. It means that it is imitating human intelligence. The term AI then dates to 1956. So I think, Sigrun, you might win and say 1953. And also the neural networks, which is the big thing being hyped up in the last 10 years or so. It has its predecessors in the 50s. So the perceptron, the first artificial neuron, once again, it doesn't mean that it's an actual neuron. It just means that it is imitating a human neuron. So you have multiple outputs being weighted to generate, you have multiple inputs being weighted to generate one output, yes or no. That's a perceptron. And the term machine learning is also from the 50s. As it's also, machine learning was used to program a checkers algorithm. Not yet chess, but checkers computers in the 50s. Then there's something called the first ice age of AI, and we go to the 80s, which is just when there is more readily technology available. Of course, 80s is also when personal computers become available, but we're talking more importantly of the big mainframe computers in the basements of big businesses. Interestingly, the Chinese Association for AI is also from 1981. That's just, 3 years into the Geiger Kaifang, the reform era, and it's already Association for AI being formed. I found that really interesting, how far back it all goes. And another important stepping stone is the backpropagation algorithm, which is basically supporting the existing perceptron by teaching it to learn from itself, let's say. But even this innovation, it didn't lead anywhere in the 80s, at least not very far, because what is really important for this all to work is a lot more computational power. And this is really the most important development of the new millennia. It's not so much new innovations, even though we have some new innovations, like some specific activation functions that are being established in the 2010s. But far more importantly are two developments, which is one is much more data available. So we have huge collections of image and data text data that machines can use to learn from. And second, we have much cheaper computation power to really use these theoretical inventions, which date all the way up to the 50s, but only now it's really feasible to use these large scale. Okay, and of course, you all know the big hype of the last 10 years or so are these transformers, especially GPT, which is focusing on the decoder part. And maybe just quickly, I think you all know probably how GPT works. So it's being trained on this massive, huge amount of data, mostly, I think, copyrighted, but who cares? And it's looking at where these tokens, for the ease of it, let's say words, how they appear together in these texts in order to learn how things relate to one another, which words are often being used together, how grammar kind of works. All of this is being taught indirectly to the massive flow of information of training data. And what's different from the transformer to the predecessors to something like a CNN is that it is training the embedding of the words of the token in relation to all other tokens. So it's not just looking at what comes right before that token, but it's really looking at the position of that token in the entire context window of multiple sentences, and therefore being much more capable of learning the meaning and the correct position of these words or information in general. And then it is capable, therefore, of forming these sentences which look really natural and look as if you're talking to a human, which you are not. It makes it sound as if it's intelligent, which it is not. But this is all thanks to the massive amount of data that's being put into it. It can generate these nice outputs. Now, as I said earlier, this is not a presentation about digital humanities in general. And I think it is not so easy to really talk about or to define AI vis-a-vis computation, vis-a-vis digital humanities, vis-a-vis machine learning. So I try to create this sort of schematic, and maybe it helps to make sense of it. So if the whole screen right now, the whole red surface, that's all computation, and therefore we can call all of that digital humanities, then within this, there's a subset we could call AI, which is sort of using the computer and the computer algorithms with a specific goal in mind. So if we research a question and we're using the algorithms to answer a specific goal, we have an aim directed at it. And then within this subset, we have something called machine learning, where the machine is learning for itself how to answer the question. I will go more into detail in a moment. But then in that machine learning arena, we have yet another subset we can call deep learning, or also we call it neural networks. And this is where all the fuss is about. It's within the subset of a subset of a subset. Now if we think about where can we put different methods that we know that you might have heard into these different fields. So if we start about, let's say we're using Microsoft Word text processor, what are we doing? Are we doing AI because we're using a computer? I think it would be stupid to say that. It's really stretching AI too far. But I mean, if we want to say we're using computer, we are doing something digital, I guess we could call it digital humanities in some sense. But it's really at the far edge of our schematic here, would be text processing. Now, if you think about something like OCR, optical character recognition, which is, as you know, when you scan a document and the computer will tell you, it will estimate the words or even the structure of the document scanned, OCR. Where does that fit in? It depends. I mean, 20 years ago, probably it's basic computation, but nowadays, depending on what software you're using, how the OCR is being done behind the scenes, you might be doing something that could be equated to machine learning, even though you don't know about it, what the computer is doing in the background. If you think about these network graphs, you've probably seen them somewhere if you've visited any presentation about digital humanities, because DH scholars love these network graphs because they look very fancy. Graph theory itself is just mathematics. It's not even intelligent if you think about it. But depending on what you do with these network graphs, it might become intelligent. So if you, for example, use certain clustering algorithms to find a hidden structure in these networks, then suddenly you are doing machine learning. Or if you think about GIS, mapping software, geographic information systems, if you're just using the software to create a nice map, it's not so different from using Illustrator or Photoshop. You're just using computer and doing what you want to do. But if you're using GIS to maybe use satellite data to find data on land use and do that automatically, then you might even go into the realm of deep learning. So it really depends on what exactly you're doing with these kind of softwares and methodologies. Depending on what you're doing, you might fit in a different rectangle here. You probably also have heard about this term supervised learning and unsupervised learning. So supervised learning means that you already define the output. For example, you want to teach the computer to distinguish between a cat and a dog. and you tell the computer that all the photos you're feeding it are either a cat or a dog. That means you're doing supervised learning. The computer will learn to distinguish the images between a cat and a dog, but you predefine the categories, the boxes in which these images fit in. Also, all the regression that economists are doing, that you're doing business intelligence in data analysis, that's all supervised learning. Meanwhile, unsupervised learning is when you do not tell the computer in advance what categories are the output. So the computer will get 200 images of cats and dogs, but you don't tell them that they're either cats and dogs, and the computer will decide by itself how many different categories are hidden in these images. And maybe it will come up with cat and dog, maybe it will come up with cat, big dog, and small dog. You don't know because you're not teaching the computer. The computer teaches itself what the outcome might be. Finally, we have these neural networks, which means we this is when the machine learning is modeled as if or somewhat similar to how neurons work in the human brain. And these different layers of neurons put after one another. And we can use these neural networks to do all kinds of fancy things that are popular right now. So we can do the language modeling, like in the ChatGPT, and we can generate data. So the ChatGPT is, of course, generating data every time it gives an answer, but you can also generate images that did not exist before. You can, if you think about surveillance cameras, for example, in China, you have these public surveillance cameras, and the computer can detect how many cars are in the picture, how many passengers are on the street right now at any given point in time. These kind of pattern recognition skills are also based on neural networks, or estimation, time series estimations, or also fragmentary data to completed fragmentary data. All of this can be done with deep learning. Now, if we think about connected disciplines, if we think about, also have NLP here, natural language processing, is another term you might have heard. Once again, it depends on how the NLP is being done, what generation of NLP you're using. It could be anywhere from very basic AI to deep learning. So this is about understanding sentences, sentence structure through the computer. Now, if we think about aligned professions like data analysis, how does that fit in? Once again, it depends on what the data analyst is doing. If they're just doing Excel, it would be far-fetched to say they're doing AI. But if they are doing more advanced data analysis, if they're doing regression models, for example, they might be further in the center of this schematic. Similar for software engineering, coding, programming. Depending on the language you're using, depending on the goals you have in mind of what you want to achieve with your code, you might require different languages to achieve that. So if you're doing data analysis, you might be doing R or SQL, while if you're doing more something in the neural network domain, you might be doing Python, or if you want to go more low level, you might even need to resort to something like C or C++. So if we skim over the different common methods that are relevant also to the humanities, and only concentrate on the more like central rectangles of our schematic, and the supervised learning, unsupervised learning, and the deepened learning. We have things like regression, which is something that was popular way before the whole AI buzz started. The economists have always been doing linear regression, logistic regression. We can think about something like classification. You don't need to know all the stuff that's being written here in the brackets, but these are different sub-methods that are being used for these different tasks, like k-nearest neighbor, random forest. These are different kinds of ways to classify things. Unsupervised learning means you might want to do something called clustering, which is basically meaning we, as I just said, we are not telling the computer how many classes, how many groups of data there are, but the computer decides itself how many logical clusters the data can be divided into. Dimension reduction means we have many variables, that might be partially linked to one another, and we want to reduce these dimensions, these variables, these factors into, let's say, a three-dimensional space or two-dimensional space, and we can do this through different machine learning algorithms. Or we can do something called structure discovery, which is something I will go later into detail. I know this all is very confusing right now, but I just want to give you a brief overview about the vast landscape of AI, because many people, when they hear AI, they only think about ChatGPT, but actually ChatGPT is just such a small fraction of AI. So I want to give you a brief overview about the different methods associated with AI. So structure discovery, for humanities scholars, most importantly, topic modeling is when we have a big corpus of texts, for example, and we want to ask the computer, is there hidden structure in these texts? Are there patterns? For example, do all of these texts talk about the same 5 topics? And if so, which text belongs to which topic? So without reading these texts ourselves, we can use structure discovery to ask the computer to divide these texts into topics for us. And finally, we have here deep learning, where we have different architectures of neural networks. So we have the convolution neural networks, CNNs, which are mostly used for visual tasks. So this is when the computer learns which pixels often appear together with one another. And this is, for example, being used to detect cats on images or passengers on security cameras. We have neural network architectures called recurrent neural networks, which can be used for data generation. So the machine knows a certain pattern and how this pattern usually goes on from the big amount of training data we fed into it. And if we feed new data into it, it can estimate how this sequence is probably going to go on based on what it has read in the past. Then we have the transformers, which is the big thing at the moment. All the large language models like ChatGPT are based on transformers. And transformers are basically the successor to RNNs, if you want to say so. So these can be used to model language, also for modern translation engines like DeepL, these kind of things. They're all reliant on transformers. And finally, the fourth deep learning architecture that you should have heard of are autoencoders. Autoencoders, a specific architecture where basically one machine is trying to outplay the other, to outwit the other, meaning that it tries to cheat the other machine into believing that the output is not machine generated. And this is used to train the machine to, for example, to draw very realistic photos. So the machine is cheating the other machine so long until the other machine believes that the machine is actually showing them a real photo, for example. And you all know that this can be used for very bad purposes like deep fakes, but it could also be used for restoration purposes or for estimating fragmentary information in archives and so forth. So all of these different methods have the use cases in medicine, in robotics, in business intelligence, in science and mathematics, in economics and finance. But the case is not as easy to make for humanities. And that's what I want to talk to you about today is, are any of these methods relevant also in the humanities? So if you think about these methods as mere tools to advance our already existing research, so if we say AI will not be really the base method of our research, but we want to use AI as sort of as a tool, as a almost like as a co-author, but as a player that is playing internally with us as we are writing our paper, for example, then I think AI, of course, has some legitimate uses. And My colleague Christian Henriot recently wrote this paper. He published this kind of a discussion paper, which I found really interesting because many people in academia, they kind of think that using AI in research is kind of a bad thing. It's almost like plagiarism, like you are not writing your paper yourself anymore. And Christian was really like truthful and in this paper and really showed how he thinks that he's using AI in a really legitimate way of doing his research. So he writes, for example, how he is enhancing his literature review, not by asking ChatGPT, give me 10 interesting papers, because ChatGPT is hallucinating these papers, they might not really exist. But no, by collecting the papers by himself, but then by using machine learning methods to, for example, say, I have these 500 papers. I'm now going to use topic modeling to cluster these 500 papers into different themes and different topics to give me sort of an optimized literature review about what past academics have been writing about to make sense of the big data. Or, for example, to read texts that were written in Russian or any other language that you might not otherwise be capable of reading. So these might be legitimate uses of using AI in preparing your research. You might also be using AI to extract important names, dates, and locations from these materials, from your secondary literature or even from your primary literature, to prepare an overview of the data that you have at hand. Or you might use AI, especially large language models, to enhance your writing style, which I think is legitimate because not everyone is born in an English-speaking country, and we should all have equal chances of writing our papers. And you might even use them to create visualizations. I believe even the visualization of this paper was created by AI. So these are ways of using AI as tools in research, but I now want to move over to using AI as methods in our research, which are arguably overlapping topics. And as you've seen in the table of contents, I'm dividing this into 4 different subsections, into 4 different kinds of patterns, which we can discover and explore by using AI on our available data. And we can think about this in 3 different sort of categories. First is data retrieval, which is sort of coming at the very beginning of our research. We can then go over to distant reading and data analysis, so making sense of the data we have assembled. And third, we might also be using AI in presenting our data. So data retrieval, this could, first of all, start with visual archive retrieval, meaning the archives we are using, the online archives we are using might use AI in order to make sense of their own archives. I will give some example later on. We might use AI to extract data from our primary data and clean the data. So this might be if we have badly scanned documents. We are using the OCR, but actually the OCR is always interpreting our scan line as some characters. Then we might use basic data analysis methods, data cleaning to get rid of these of this meaningless data in our documents, for example. So we can clean our digitized primary data using some available methods. We might also resort to AI for the OCR itself, as I will give some examples later on of some new OCR that's using neural networks for better results. We might use AI to segment our sources. So for example, we have these scans of newspapers and they are 1 page, but actually on 1 page you have, let's say, 10 different news. And the historical newspaper, they might have different sizes of boxes for each news in each volume in each day, right? And we want to automatically segment each page of the newspaper into just each article. And we might also be able to automate this kind of task. We may use AI to find out what is being written about in our primary data. So we can automatically recognize famous names or places that are being written about. And this is possible through the computer sort of understanding the language and sort of understanding what is the geographic entity in the sentence, what is a character or existing person in a sentence, and so forth. And we may also use AI to restore visual fragments. So if something is incomplete, to help us guide our research. For the more important part, the distant reading, there are things like topic modeling, which I have discussed earlier and will discuss again in a few minutes. Sentiment analysis is another thing that I will talk to you in about a minute. Network analysis, sequence analysis, historical geographic information systems. These are all methods for which I have case studies, which I will present to you in a few minutes. But even for the presentation, so what's being done after the research, we could use AI. For example, if we have basic understanding of how to do a nice website or a nice visualization of our research outcome, but we might need help in finishing these websites. For example, we might seek help from ChatGPT or more, or an AI that's being programmed for the specific purpose, like Claude code to help us code or program our outcome into a website that we can show off our research outcomes. Now, to give you some examples that I have been promising for the last 20 minutes or so. The first kind of patterns I would like to talk to you about are patterns in archives. And the first example I would like to show you, and the literature is always, of course, cited here if you want to see the original papers. The first example here is historical image reuse detection. So the authors here, they wanted to see how photos that are being sold as licenses to different Chinese newspapers, how they're appearing in different publications. So we have a photo, who is taking this photo, and they worked for the press, and the photo has been used in different occasions. And the photo might appear in different journals, some in black and white, some in grayscale sepia, sometimes cut off, sometimes mirrored by 180 degrees. And of course, you could manually go over every single newspaper to find this photo again, but it's not very sensible. So instead, you could use AI to find the photo for you in all the available newspapers in the Shanghai Library, for example. This is one good example. Another example is, as you know, it's all digital, so it doesn't matter if it's actual text or image or audio. It's all 0 and 1, so you could also use it for audio. So here you have a paper where the persons, they knew that their archive at the Chinese University of Hong Kong, they had this collection of chanting. But the audio tapes, they also heard like interviews and silence and all of the stuff in between them. And they were only interested in getting the chanting of these audio tapes. So they used the machine to train the machine how chanting looks like what kind of audio waves signal chanting, and then automatically filter out all the chanting from the available audio tapes. So this is another example of how archivists or also historians can use AI to get a better grip on the available data. And the third example here, fragment restoration. Here the researchers had these collections of oracle bones. They're all shattered to pieces, as you know, for divination purposes. And then instead of by hand trying to piece them together, they taught a computer to rejoin these oracle bone fragments where it makes sense. So this is how you could use AI for archival patterns. The next I would like to talk to you about is patterns in text, which is probably the most important kind of patterns for humanities scholars text. beginning by OCR. So you might know this OCR by Academia Sinica, which won many prizes in the late 2010s, which was built using CNN, a type of neural network architecture. And this is also really useful for classical Chinese texts, whereas the most commercial OCR would be based on commercial contemporary Chinese. But it gets more exotic. So nowadays, people are building models, for example, for OCR-ing three-dimensional oracle bone scans and finding the characters on the oracle bones. Or actually, here at UST, my colleagues are working on the Manchurian OCR. On the right side here, you can see a website where you can also test your own images, and you can kind of click through different models, different commercial available GPTs, which are not really trained to do these tasks, but you can still try and see and compare different available commercial models and see how they can OCR your own images and see if any of them give you a good result. Another method I would like to introduce to you, which is really helpful for me in distant reading, if you have a lot of corpus. For example, I work on Republic in China, and we have this huge collection of journals, of newspapers from Republic in China, but it's really impossible to read all of it. And for me, it always seems that historians like to write about the most prolific authors or the most famous authors or the ones they like the most, but it's not necessarily the most relevant authors at the historical time. And it's really not easy to even identify the most relevant authors or most relevant debates, the discourse of a given time by hand. But if we use topic modeling, distant reading, we might be able to make sense of the big data and identify discourses in time. On the left side, you see an example where the author used issues of the New York Times, and they looked at all the articles mentioning China and identified different topics in which China appears. So there's like the topic 0 is the Russia-Ukraine topic, or on the topic 4 is the spy balloon topic, or you have the economy topic, you have the zoo and panda topic. So you have different topics that can be identified without you having to ever have read the New York Times by yourself. And this is really, I think, also relevant if you do qualitative work. So even if you say, I'm a qualitative researcher, it still makes sense to kind of navigate in the big data first and see where your qualitative study is situated within the broader discursive window. On the right side, you have a more historical example from my colleague Cecile, who did this for the Schönbau, for example, and looked at topics that the Schönbau was talking about in a certain time span. Another special case is sentiment analysis. So whereas topic analysis is a form of unsupervised learning because we don't teach the computer what kind of topics to look out for, in sentiment analysis, we do teach the computer what kind of different sentiments there are. So it's supervised learning. So here you have an example where the author looked at different social media posts during COVID in Chinese media and identified how social media posts at first are mostly fearful and then lead over to anger and sadness and then to surprise. And you could even distinguish certain regional clusters. So the people in Wuhan were especially fearful in the beginning and so forth. This is something I think digital approaches are really helpful, because imagine if you'd read all of these tweets by hand, and even then you'd just have to say, believe me, I've read them, and this is what these posts are about. Whereas if you have the available data and you do the data analysis, you can really kind of make your case through the numbers. And I think that's really helpful for your research. A kind of controversial idea is if we can use AI to extract knowledge. So if we have text, we usually talk about unstructured data, meaning sentences, descriptions in real language. That's normally unstructured data. So can we use this unstructured data and ask the AI, please turn this unstructured data into structured data? Let me give you an example. Let's say you have the yellow pages. You all remember the yellow pages. There were these huge books that give you all the phone numbers of all the companies in your city. And you could now tell the AI, please extract all the phone numbers from the yellow pages. So you could prompt engineer ChatGPT, here's the PDF of the yellow pages. I want to have all the phone numbers in this PDF. And there are certain problems with this approach. First of all, by the concept of the transformer will never give you the same answer twice. So it's not exactly reproducible, even if the answer will be more or less correct to whatever, 99% if you're lucky. It will never be exactly the same answer if you ask ChatGPT again. And second, you don't know what exactly ChatGPT did to give you the answer. Whereas if you'd code your own algorithm, let's say you have and this is really easy in data analysis. You just say output all the Unicode blocks that are numbers and not words, right? And whenever more than 8 numbers appear together, that's a phone number. You don't need AI to do that. That's basic programming. That's really basic coding. If you do that by basic coding, this task takes 5 seconds. Whereas if you ask ChatGPT to do that, the task might take half an hour, and you have used a lot of CO2, a lot of resources, computing power to do the task that you could have done in 5 seconds using much less computing power. And by the more basic approach, it's actually reproducible because you have your line of code of what you have been doing. So knowledge extraction, although it is possible to use AI for this task, it is the discussion if it's actually a good use case for AI to do this kind of task. Next, patterns in lives and biographies. So if you've ever ventured into the domain of China-related digital humanities, you probably stumbled upon some biographical databases. You probably stumbled on the CBDB, the China Biographical Database, which is mostly maintained at Harvard, and they collect thousands of biographies of gentry personnel in imperial China. And there are also other databases. There are similar databases on modern China and specific databases, some of which are hosted here at UST, some of which I have been taking part in, like the engineers database. And these databases by themselves are not AI, of course. They're just structured data sets, which you can use for your own purposes to explore, to find a name, to find a biography you find interesting. And there are certain criticizes of digital humanities, which say that for too long of a time, digital humanities was just busy digitizing data. So digitizing and structuring analog data, putting it into data sets. And what people like Law here in an essay 2020 says is that AI and machine learning allow us to finally go beyond mere digitalization to deeper knowledge discovery. So we can use data sets that we already have, that we have already digitized, and now apply AI methods such as network analysis, sequence analysis, spatial analysis, forms of unsupervised learning to make new sense of the available data. So what this means is we should think about not just digital, but computational humanities. So the data sets, if they're open, if they are freely available, and you are a digital expert, you can use this data set and use AI to make new sense of it. So for example, if we think about network analysis, you all know these nice graphs and they look really fancy. They sometimes look like a universe and a whole Milky Way, and they look nice, and you see, wow, there are thousands of people and they're all connected to one another, right? but it's really difficult to make sense of them by itself. So network analysis by itself is a study of interconnected nodes or vertices, and they're somehow connected. There might be mutual family, mutual workplace, mutual friends that are connecting these different people in a network. You might know this game, 6 Degrees of Kevin Bacon, that everyone is connected to the actor Kevin Bacon by 6 degrees somehow. But how do we make sense of these really vast networks? And one idea is we can use machine learning, unsupervised learning, to divide these big networks into clusters. So we, by our eyes, cannot make sense of these vast networks, but we can use clustering algorithms to have the computer help us in identifying patterns which we cannot see by our own eyes. So that's community detection. And I've done this, for example, for Republican China in a recent publication here, Modern China in Flux. You can see many examples of how network analysis can be advanced by clustering algorithms. Another example is sequence analysis. Sequence analysis is actually coming from DNA and RNA analysis in bioinformatics. It was primarily used to make sense of DNA, but historians and sociologists have somewhat appropriated this to make sense of biographies. So we can use sequence meaning a life sequence. So when is someone born? When is someone getting a job? When is someone getting a second job, a promotion? At what point are they married? At what point do they get kids? This is a sequence. And if we have 10,000 historical sequences of, let's say, Chinese Republican personnel, we can then have the computer help us identify certain clusters, certain stereotypical sequences. What's a typical sequence of a historical person at a certain decade? And why are some sequences different from other sequences? How are they privileged, or are they geographically different, and so forth? That's another example of how we can have machines help us make sense of vast amounts of biographical data. The final and last example is patterns in space. So spatial analysis is everything where we have geographical space and we want to have analysis about distributions in space. Trade patterns, mobility, how people move, how goods move. And this is by itself not AI. But so for example, this is a project by my friend, Professor Kwong at Baptist University. And he has been collecting all this geospatial data on Hong Kong in the Second World War during the Japanese occupation. And by itself, it's not AI, right? It is digital humanities, but it's not AI by itself. But we can use digital means to identify clusters of resistance. What do resistance clusters have in common, for example? Are they all in the mountains, or are they all, near factories, for example? So this is something we can use AI to help us and identify certain patterns. I'm going to quickly jump over it for time constraints, but we can also use AI to make sense of archival maps, for example, to automate digitizing maps as features and then help us identify, for example, city growth historically, urban build-up, land use, all of this kind of stuff. We can use AI to help us in making sense of available primary historical data. Also, I'm going to jump over this because we don't have so much time. But I want to close this overview about what AI is, about what machine learning is, about how we can use AI in humanities research with a few final remarks. The first remark is an advertisement. In 2 days, I'm going to have a presentation also on Zoom you might be interested in, which is the launch of an atlas of a database on East Asia-related research in northern Germany. And this is mostly just a digital humanities project I've been working on, but there's also a little bit of machine learning involved in assembling this database. And I'm going to talk about all of that in 2 days. So if you're interested in it, you can Google this title, and you will find a Zoom registration link somewhere via Google. The second thing is, I want to point out that digital humanities scholars have been organizing in the Sinophone world for quite some time. So there are centers for digital humanities. The first one should have been in 2011, opening in Wuhan University, and a year later in Taiwan at the NTU. And the NTU is also giving out this journal of digital archives in digital humanities. And while most of the publications are not strictly AI related, some of them are. And there are also regular conferences. The longest running one is the one also hosted by this center in Taiwan. And another new one now in its second year is the Hong Kong Association for Digital Humanities International Conference. The second one will be in January this next year. And you will find some AI-related research there as well. Finally, to kickstart the discussion, I would like to maybe just put up some statements, and you might not agree with my statements, so they could be helpful for our discussion. The first question is, how can we integrate AI-related research in our existing humanities curricula? Is it even feasible? And I think it's not realistic to teach everyone how to code, but it is feasible to at least teach students or even pupils what AI is. So to get away from all of this, Bitcoin Bro talk, tech bubble hype talk that you find on LinkedIn, where people write about AI without knowing what AI is, and to really teach people about what AI is in order for them to be critically able to engage with the idea, to reflect on terms such as intelligence, awareness, and consciousness, and to have a very basic understanding about what ChatGPT is doing. Second, to understand the difference between methods and presentation of methods. First of all, I think we should make clear that not every DH project needs to be AI. So it's perfectly fine to practice digital humanities without integrating AI means. Not every research question necessitates AI just because AI sounds fancy. And second, also not all of your digital project needs to be an interactive website. So it's still this idea that if you have a digital project, in the end, you have this website that you show off to everyone. But actually, DH and AI are just a collection of methods that you can write papers with, but it doesn't need to be, in the end, a general audience website. That's, I think, a misconception. Finally, I don't think that every scholar, every humanities scholar will ever need to become a coder or will ever need to be able to use AI sophisticatedly, just as, I don't think it's gatekeeping. I think that if you're an art historian, I am not an art historian. I don't know about art history, so I will not write art history papers. And if you're not an AI scholar, you don't need to be able to write AI papers, and that's totally fine. I think it will remain a subsection within a really big humanities field, and I think that's totally fine. AI does not need to be everywhere. But as I was hopefully able to show you, there are very specific research questions, very specific niche where AI does make sense and where AI can advance existing humanities research and where AI can help make sense of existing primary data for your research questions. So with that, I would like to open the discussion. Thank you for bearing with me and for the audio problems in the beginning. And thank you very much for your attention and for your time at your lunch break. Thank you very much.